Welcome to tonight's video. Today we're going to be talking about solving inequalities. And you probably noticed this is the last page of notes in this packet. It's just the 3 that we did this week. So on Tuesday we talked about writing inequalities. That's where I gave you a math sentence and you converted it into something that looked kind of like this. Then yesterday we talked about graphing inequalities on a number line. So this is the final video for this section, and it's going to be called Solving Inequalities. So now what we're going to do is we're going to take something like this where x isn't by itself on this side, and we're going to get it all by itself to figure out what x is less than or greater than. Okay, so before we start on that, we have a couple properties here for you to learn about. So the first one is called the addition and subtraction property of inequalities. So remember, a property is like a math rule, and that's something that mathematicians came up with a long time ago when they tried it and they knew that it worked every time. So this first one says that whenever we add or subtract the same value from each side, it remains true. So just like what we saw when we were solving equations, if I add the same amount to both sides, it's going to stay balanced. Or if I subtract the same amount, it'll stay balanced. It'll stay true. So we're going to see what that means here in a minute when we try this example. But first, I also want you to write down the definition for this one. This is the multiplication and division property of inequalities. So this rule says that when you multiply or divide each side by the same positive number, it remains the same. Okay, and that means if we multiplied by a negative number, it'll change things, but you're not going to learn about that till 7th grade, so don't worry about negative numbers right now. Just know that if you multiply both sides or divide both sides by a positive number, it's going to stay balanced. Okay, or it stays true is what I should say. Okay, the first step here now to solve this then is to start by drawing our railroad tracks. Okay, so I know it's been a while since we've done this. We did this back before Christmas, maybe around Thanksgiving time. Okay, we drew these railroad tracks. Do you remember this? So we do that so we see where our equal sign was, but now we have our inequality symbol, and that's okay. So we've got that guy in there. So we draw our railroad tracks on both sides of our inequality. The second thing we are going to do is circle the variable and anything attached to it. So we want to see if anything's in front of it. So if we look at this, we have an x, that's our variable, and it has a plus sign with it. So we're going to circle that. Remember, it's got to be in front, not behind it. The next step is to use the inverse operation to get the variable by itself. That's what we mean when we say isolate the variable. Get it by itself. Get it by itself. Okay. And inverse, remember, really means to do the opposite. Okay, so what that means is I'm going to look at all the other stuff on this side. So I've got the x all by itself right here in my circle. I need to get rid of the stuff outside of my circle, so I need to get rid of that 3. I can see that that's a positive 3, so if you want to draw a little box here to remind you, right now that 3 is positive, so I've got to do the opposite, which would be to subtract, and the amount I'm subtracting is 3. So if I look at that, I'm going to do minus 3 from this side. And since I'm doing it to this side, I have to keep things balanced. I got to do it over here. So right now, all I'm doing so far is subtracting 3 from both sides. When I simplify that, I have 3 take away 3. That cancels out. It becomes 0, right? You can write the 0. You don't even have to write it. You can just cross them out. And I'm left with my x right here. If you want to write that plus in front of it, you can, but you don't have to if it's positive. Okay, my inequality guy, he comes right down here, and he stays the same. And then I'm going to subtract here. 10 minus 3 is 7, and I'm done with that step. Now I'm going to check, is there anything over here? I'm going to cross out my 0. I don't need him. I just have x less than 7. I'll rewrite that down here without the railroad tracks in the way, x less than 7. Now we know what to do with this. So from here, now we're going to graph it on the number line just like we did yesterday. So we're going to draw our number line down here. We're going to put 0. 0, remember, he's just there to help us know where to put the rest of our numbers. 7 is on this side of 0 because it's bigger than it. If you want to draw all your little lines in between to count up to 7, you can, but you don't have to. You can just say 0's here, 7's over here. That's good enough. Okay, now remember we've got to decide. We've got our numbers on our number line. Our next step is to decide if we need an open circle or a closed circle. This is a less than symbol, so if you look back to yesterday's notes, less than has an open circle. Remember, anything that doesn't have that equal bar underneath is going to be open, and only these two, so less than or equal or greater than or equal, those are the only two that get that solid dot right there. So this one's going to be open, and remember, he goes on the same number that I have here. So my open circle goes at 7. Okay, now I need to decide which way to go. X is less than 7. So if x is less than 7, that means x could be 6, 5, 4, any number smaller than 7. So I'm going to go towards the 0, towards the smaller numbers. I'm going to go that way and make my big dark arrow right there so I know which way to go. Okay, and then I'm all done. So if we finish writing in our steps here, it says that number 4, we are going to graph our solution on a number line, and we always include 0 on our number line so we know if we've got positive or negative numbers and which way everything's going. So those were our steps. We started with our railroad tracks. We circled this variable to see what we needed to get rid of. We decided that we had a positive 3, so we needed to subtract 3 to get rid of it. So we did that to both sides. When we subtracted 3, we got x all by itself. That's what we wanted. If you mix up and get the wrong sign here, you'll get more stuff over here, and we don't want more stuff. We want to get rid of stuff. So we got rid of our 3. We subtracted 3 over here to keep everything the same. So now we had x less than 7, and we were able to graph that. We saw that it wasn't equal, so we put it there, and we drew our arrow. Okay, let's go through just a few more examples. You can see that these ones look a little bit trickier, but we can do these. They're not too bad. Okay, so first things first, we draw our railroad signs on number 1 here. I probably shouldn't do it down that far. Railroad tracks, I should say. Okay, the next thing we do is we circle the variable and the things attached to it. So I have this W. Okay, that minus is attached to the 5, so I'm not going to circle the minus, just the W by itself. Okay, now I've got to look at what's left. So I do have a minus 5, so if I draw my little box up here, my 5 is negative. So the opposite of that is to do a plus, a positive. So I'm subtracting, I want to add, and the amount is the 5. Okay, so that and that should match with this guy here. Okay, so if I'm subtracting 5, I'm going to do the inverse or the opposite, and I'm going to add 5 here, add 5 over here. Okay, so we've done step 1, step 2, and step 3. So we're going to finish solving all of this. So my W, he comes straight down. Negative 5 plus 5, those cancel. My inequality symbol, he just comes straight down. And then I'm going to add these two together. 15 plus 5 gives me 20. So I now know that W is less than or equal to 20. So now I got to draw my number line. I know that 0 is going to be here. 20 is going to be up here somewhere. Do you see how this makes this easier just to do 0 and 20? Then I don't have to sit and draw 19 little lines in between here. That would take forever. Okay, since he's less than or equal, I'm going to have my solid dot right here, or my solid circle. And I've got to decide which way to go. So less than or equal, is 21 less than or equal to 20? No, that's the wrong way. What about 19, 18? Yes, those smaller numbers are all less than, so I've got to go this way again. Okay. Number 2, same idea. We're drawing our railroad tracks. And we're going to circle our variable. And you could circle that 6 as well, because that's attached to it. Do you see how that 6 is attached directly to our B? Remember, the operation that does that is these are timesing together. They're multiplying. So the opposite of that, if we draw up here, we have our times. The opposite of timesing is to divide, and the number we want to get rid of is that 6. So we're going to divide both sides by 6. To do that, we draw it kind of like a fraction. Okay, 6 divided by 6, those go to a 1. They cancel out. So I'm left with my b right here. My inequality guy stays right there. What's 48 divided by 6? You can check your multiplication table. When you do that, you'll see that 6 times 8 is 48. So 48 divided by 6 is 8. There's my answer on that one. So now we're ready to graph. Okay, so for this one, I'm going to always start with my 0. 8 is positive. He'll be over here somewhere. And now we're ready to go. This is greater than or equal. Because that equal bar is there, I get a solid dot right at 8. Remember, I'm always graphing at the number that they gave me. So the 0 just helps me set this up, but my graph starts at 8. Okay, b is now greater than or equal to 8, so it's bigger than 8. So do I want to go down towards 7, 6, and those guys? No, I want to go the opposite way. I want to go to the bigger numbers, 9, 10, 100, all of those numbers that are bigger than 8. So my arrow goes that way, even though he's short. Okay, over here on number 3, same idea. This time we are drawing our railroad tracks. Don't let that fraction scare you. It's not going to be too hard. Okay, I circle my variable. He's got nothing attached to him, so he's right there. Okay, so what's left over is this negative sign or this subtract sign and my 1/4. So up here, I have a subtract. The opposite is to add, and I need to do that with the 1/4. Okay, so P's going to stay here by himself. I'm going to add 1/4, add 1/4. Those are going to cancel, so over here I just have P. I have my inequality symbol. 2 plus 1/4. Okay, there's 2 ways you can do this. We showed you on the bell work the other day how you could convert this to a fraction and combine it. You can do that if you want, but because this is a whole number and this is a fraction, isn't 2 plus 1/4 the same as saying 2 and 1/4? It is. You can just leave it that simple. On the other one, we were trying to multiply and add and do all these other things, so we kind of needed to add them together as an improper fraction, but for today, that's going to work. 2 and 1/4 is the same as 2 plus 1/4. It's like if I have $2, I add 1/4, 2 and 1/4. Okay. So we have this, and some of you look at that and you're like, how do I graph a fraction or a decimal? It's not that bad. So if we look at this, we know we have 0. 2 and 1/4, is that more than 0? It is. It's over here, and we can just label that point, 2 and 1/4. If you really wanted, you could do a 2 and a 3 and kind of guess somewhere in the middle, but you can just label that point 2 and 1/4. Why not? So, because this is greater than or equal, I'm going to have my solid dot here at 2 and 1/4. Now I just need to decide which way to make my arrow go. So if P is getting bigger than 2 and 1/4, I'm not going to go that way. That would be smaller. I'm going to go same direction as the last one. I'm going to go this way to the right and draw that in. Okay, I will let you try these next 3 on your own. On this one, remember the fraction means to divide. That's your first one, so you're going to have to do the opposite of dividing. I'll let you figure that one out. Let me know what your questions are. I'm happy to help you in class. See you tomorrow. Bye.